Uh, so yeah, hi everyone. Uh, so this is the talk about the React state management, and the thing is like, why did I felt a need of giving this talk is I learned something recently, and I felt like it was something good, which was kind of I seen like some multiple implementation of different things, and some point where we are missing out some very fine, some very minor details, which kind of lead to very unintended bugs, and that's the whole reason where I had a thought of giving this talk. So, yeah, let's get started. The first thing that before I start the talk about this state management, what I would like to get out of the way is something that is very fundamental. I'm sure like pretty much most of you might already be knowing is that like how modular the React is. The thing is like the flexibility what React provides, and how does React is achieving this is because of what it is maintaining down the line is, under the hood is a tree structure, uh, kind of a tree data structure that it does have, which is like something which is coming from this HTML XML structure as well, where if you see like this is the same page that we are seeing. Now, if you see the design of it, it has been segregated into different smaller chunks and are considered are just a node in a tree. That's how it is. So if I start from the, let's say, app, that becomes our root node, and then div and header and welcome, and like the header is having multiple children. So why I want to do particularly focus on this point is like this very fundamental fact of React is like something we do not like very much emphasize on and very much realize to make our code very smooth and efficient as well. This kind of gives us the flexibility of doing the code splitting, dynamic loading, and like even making a very small module of our site into React. That also we can achieve, and also composition. So there are a lot many benefits that are just we can achieve based on this simple fact that React is under the hood a huge tree data structure that is used to render the render this, you can say, UI over here. So, okay, so this is the first thing that I wanted to talk about. And so, yeah, so, now this is out of the like this is we have done what let's starting with the React state. So what is a state? Let's talk about that one first. So whenever we want something to be dynamically be changing, as in something which is defining what are at a particular instance of time, what your application, like your application is in what state, that is what and that is with a particular value, that is what the state is. Okay, and there are two things, and that is one thing that the data that we are seeing here, which is a static one, and the state that we are going to talk about is also the UI state, so this is something that I want to address because let's not confuse this with the server state. So let's say if we have an input box, if I'm entering a name, that state is going to the backend and stored. That is not the state that we'll be talking about. This is all that we are going to talk about is the UI state. All right. So now let's start with like the first thing that we would want to discuss is in the state. The first thing that will come is the useState hook that the React provides. This is the very basic, you can say, the fundamental point where the React starts doing the state management, and this is how we can manage the state in the and this is about the 16.8 since hooks came into picture. So and the whole talk, I'm sorry if I'm like hurting anybody's sentiment by not discussing classes, but yeah, we'll be discussing functional components with hooks, right? So and most of the logic or most of the concepts that we are going to discuss are very much applicable to the class components as well. But what we would be majorly focusing would be achieving these things with the hooks. Okay, so yeah. So the first thing is a state, and this is the very simple, you can say, way of in which the React is managing a particular value within a given instance, right? So let's say in the current instance, when I'm just rendering the app, this is the initial state that we are providing, and I'm just going and like uh, overview of what is already there, okay? And then we'll discuss like what things are available with this hook itself. So this is one thing which is like the initial value. So first time that the app is rendering, this is the value that the name would be getting initialized with. And at a later point in time, we are giving an on change, and anytime the value we are entering would be changed with this. So if I enter anything here, this is how the value would be changing. But if you see here, there is one thing that I'm right now focusing on is that the whole application, and then what will happen is like anytime the set name happens, that time the app re-renders itself. And if you see, there were outlines that were coming when I'm typing. So it is actually telling what all components are getting rendered as we are typing along, right? So first thing that I want to cover is in the state management would be the state co-location. What does that mean? Is so let's jump into some coding. So this is what I mean, the state co-location. So when we say state co-location, what is happening is when we are rendering the name, I mean like when we are changing the name, the whole UI is getting re-rendered again and again. But that is not something that we would want, right? We want only the particular this field or maybe something on this would this to change, but not the whole application to change. So that's what the state co-location talks about. What state co-location is, we should be keeping our state closest to the point where we want its effect to be and where we want to limit its effect to be. So now if we see our particular again, like revisiting the first point that we discussed, which was like the tree data structure that the React is supporting, we can, if you see like this is a structure, and here there are these two things that we see. I mean like we want them to be getting rendered again and again whenever there is a change in the input, but rest of the stuff we do not want to alter every time. So what possibly we could do is we could extract a component out of it, and let's say that component here would become, let's say, name component. All right. And what I'll do is I'll just be moving things up and down here. And let's say if I'll be extracting, okay, doing this one. Right. And what am I missing here is a fragment. So there's be empty a fragment. Okay. And here we'll be just adding the name component. This is that. All right. So now if I do any change, now this application is re-rendered. And now if I'm doing any change, the only thing that is getting re-rendered are these two, which is the name and the code, which is basically the place where we are displaying the name. So this is the first thing that the state, like this is the first point that I wanted to address with the state co-location, which talks about locating your state closest to the element or closest to the component where you want to have its effect or where you want to utilize that state, right? So that is the first part. Now, going on to the second point, and then please feel free to ask any at any point. Feel free to ask any question, or if anybody is having any doubt, just pop it up. And okay, so one more thing that I wanted to like address with the same point, like if you notice, let's say if we had some, I mean like one benefit that I could point out from here is, let's say if we had some very heavy component which was getting rendered here, component which is very having a very heavy computation or any logical calculation or something like that, that time if we are not properly distributing our state, then every time that heavy component will also get re-rendered and re-rendered. So that's where the co-location of your state even helps in making your application fast, right? So Yeah, and there is a article, there is a relevant article with this, which I could share in the chat. So let me just do that as well. So, so this is the state collocation will make your React app faster. This is the article that I have found from Kenzie Dot's documentation, and I'll just share it on the chat as well. Yeah. Sorry. All right. Now, the next point that I wanted to discuss was use state and callbacks. All right. So now, what is one more thing that we usually do is okay. So one more thing that okay. So this is the component that I have, which is a counter component, which is again on based on the same earlier topic, which is extracting things commonly out into a different component. This component we are extracted out, which is a counter component, and here we are having a state, uh, and this is the place where we are modifying its value. We are just doing an increment operation on the counter, right? And yeah, so now there is a thing that we are giving the initial state, but let's say if our initial state is getting like we are getting this initial state from somewhere else, maybe it is based on some calculation, and again like somewhere we so what I'll just do is for somewhere I'll just write a function which is like get counter state, so counter initial state, all right. And I'm just extracting this component out. I mean, like this method here, which could possibly be doing more than just returning as the state. But what I want to demo with this one is that, like, how can we like even optimize this part? Like right now, what we are doing is we are calling this method in the use state. But if you see, if like anybody can find out right away that this method getting called will happen anytime this component is getting re-rendered, right? So let's say if I open the console and I just put a console log of uh, calling this one, right? So this initial state first time got called because we are doing the initial set state, and which is okay, which is fine. But every time when I'm incrementing, the counter over here is also going to get incremented, because every time we are doing this get counter, which is not what we would want, right? So let's say if our state was coming from some API or some computational part, we would not want to do that every time on this one, right? So what React provides is a callback that we can give to the use state. Now, if we are giving this callback in the use state, what will happen is it will only get triggered first time the state is getting defined. So let me refresh this one. And now if I'm doing a count, if you see only first time it was getting the counter initial state. Now when I'm doing the increment, it is not giving the state, right? It is like not getting called. So that is the first, you can say, a piece of optimization that we can do whenever we are fetching the initial state from somewhere else, right? Moving this back again, the other very important uh, state problem that we usually face is when the state is getting updated from multiple places, right? So let's say, or maybe at multiple point in time, right? So let's say if I take an example of here, if we are doing a set counter, let's say if we were doing this, let's say twice, okay, we wanted this state to be synchronous, right? Every time we are doing these two set counter, we are basically doing a two count, right? So if I press this button once, it should increment it by two, right? Okay, so okay, first I need to, okay, so this is one, two, three. Okay, it is basically not happening twice. Why? Okay, okay, maybe it's not updating. Yeah, it is happening once only. Weird, right? So the thing is, this counter state every time whenever this method is getting called, it is getting the latest counter state. Okay, and these calls are asynchronous call. So if they both get called at the same time, they both will be having the same state and they will be updating. So this becomes kind of a race condition. And so what is a way for us to be able to avoid this race condition? So yeah, here is like, let me demo it first, like this case happening. So what I'll do is I'll make this I'll put this inside a timeout so that we can see the impact. Actually, it is not very much visible here, like the piece of thing that I wanted to demo. So maybe what I'll do is I'll put this inside a counter. And okay, so what I'm saying is here is this state is going to get updated after 1 second. Like okay, and now let's say if I come here and I increment this count. Okay, this is not getting the second counter update. Okay. Uh, okay, and let me put a console to this. Yeah, okay, this is not getting updated because it got a value of 0. Okay, so this is counter state timeout updated. All right. So let me call this one up now and clear this. Okay, so after 1, this got executed, but if you see, the state did not get updated. Reason being, when I first time when we clicked on this, the counter value was 0. It came in here with a 0 value and the increment happened. I mean, like, increment is yet to be happening, yet to happen, but the counter value is initiated with 0 here, and the set counter happened for 0 plus 1, and it happened to be 1. And again, next time it came, I mean, like, when the actual function got executed, this function, when this one was printed, 0 was added to 1 again. So at the end, we are getting the result of 1, which is not what we would want, right? We would want this value to get updated anytime we are calling, right? So here, what we could again do is we can provide a callback. Now this callback would be having a parameter. Now this parameter is actually your current value. So let me rather call this one as current counter. I'll just do this change in one place and not do it here. So I'm like, ideally we should do it at the boot place. Let me do, yeah. So if I am clearing it up and I click once again, now the first time the value 1 got updated because of this. Next time the counter state update happened and we got this current value to be at that time 1. And then the update of 1 plus 1 happened and the final value you are getting is 2. So this is how we can avoid the race conditions in the state set state, right? So let me put this one here as well. So this would be like an ideal implementation whenever we are like having any slightest of doubt of getting a race condition and our state is getting updated from multiple places where we might have asynchronous operation. So this is where this is how we can solve this particular problem. Right. So yeah, now it is working fine. Okay. Any question, any doubt? And let me know if I'm going too fast or is it okay? Okay. Fair. I'll take that as a no question. And I'll move to the next one. Right. So the next thing that I wanted to discuss with this is like, so this is what we are talking about when we are having a state within a particular component. And so let's say what will happen when I want to access this state at a multiple, I mean, like at a different level and then this particular element, right? So if I show you this counter right now, we are having our counter state in accessible in the button and code. What if my code or maybe the display of the counter was somewhere else, and so how would I address this particular issue, right? I mean, like this particular problem. So for that, what we would do is this is okay. So this is what we call as state lifting. All right. I did not updated the title name, which is very bad. So this is basically state lifting. All right. So what happens when we are extracting this code component out? Now we are saying the counter component, the earlier example, we had the state accessible within the counter component, and we were having the code here itself, right? As in like the display of the counter here itself. But let's say for some reason I wanted to display it at some part, some other part in my application. So I extracted this out, or maybe move this particular display part out from here, right? So then how will this particular segment get this state and also be synchronous with it, right? So this is the problem. So now there is one very simple approach, basically moving whatever the state to the closest parent, where you would be able to access, you will be able to make it accessible to all the children who are using this one, right? So this is simple. You can say, if you imagine the whole React as a tree, right? So every problem we are right now discussing, most of them are having their solution, you can say, baked into the this data structure itself, right? So whatever so far we have discussed, we are kind of coming back to this very fundamental concept of like React is based on the tree, right? So what I'm going to do is, since my this particular node, okay, so my currently my counter is with the button, right? And it is accessible within the counter component, but I want to make it accessible to code as well, which is basically my display part. So what I could do is, I'll be simply moving this state in here. Then how would my counter component access it? So counter component would be taking the props. So here I'll be taking counter and say handle change, handle counter change, and this is what we are going to provide from here. So first thing we want to provide is this one. Second thing is our handle counter change. And for handle counter change, rather than providing the whole, you can say, what is going to happen. So what we are going to provide is how the change will happen. So what I'll do is I'll extract this callback from here and make this one pass from here, right? And this counter, now what from where we would get it from the local state, which is now moved to the app. And here we'll be having our handle change, handle counter change. All right. So let's see if this works. Yeah. So this is working fine. But again, the last topic that we had, like previous to previous topic, which was state collocation. This is the same problem that is happening again, which is our app is getting re-rendered with this particular change. So what we should ideally be doing is extracting these two things out into a separate component and make the counter again a part of that component, right? So there will be one more node into the section. Cool. Okay. Any question so far? Or is it going too fast or too slow? I don't know. Cool.
Sorry, I have one question. So in case of this last example,
yeah,
can we use the render as a prop as an approach?
right. You can, of course, use a render prop as an approach. What I wanted to basically discuss with this particular talk, and I was going to come to this point at a very later point in time. But yeah, if you had the title of this, it was the beginner part, right? That was like a Bahubali beginner, where I wanted to just talk about the React and the React, what React itself is providing, not any design approach of how we can solve this problem, right? So these things are just what React is providing us to do things, right? And maybe in the next or later point in time, we can discuss about, or maybe as a second part of this one, we can discuss high order component, React render props, and what are the problems with them, right? Actually, they also have like not always the right solution, and in which case which one to use. Here possibly we could even do this with the composition, right? Component composition. So yeah, it is a very good point. It can be done with the render props, yes. But like with this particular topic talk, I wanted to focus this one around just the React basic, what React API is providing in itself. Is that okay?
Yep.
Okay, cool. So yep. So the next thing, maybe let's move on. So yeah, for again the state collocation can be done. So I'll not do that again. Maybe we can move on to the next point or the next topic, which is where when we said like we'll be moving the state around, right? And we'll be moving it to the topmost layer wherever the children are using. But what happens if like my multiple children's in a particular node are using a state, and some of the children are just like passing the state down, right? So with that, there is this another API that React provides, which is the context API, right? And which is like, which always existed. It's just that it was not official until like eh, until later point in time, where with the even with the beginning of hooks, this API usage of this API became very intuitive, right? And that's where this is like very good now. Like I'm very super impressed by this particular API itself, how it used to happen in the class component, and how much with just introduction of hook the use of this has changed, as in, yeah. So so what will okay, let's go over the first, what is the current code. And this is a basic implementation of context, which we usually end up finding most of the places, right? So here here the same counter example is the case. And in that counter example, there are two more additional you can say action changes, which is, one is a increment, the other one is a decrement. And what we are doing is we are creating a counter context. Now what context basically is, so it's more of like a you can say, at a parent level, you are providing some value, and you can selectively pass it along to the children, as in like not everybody needs to know that what is actually inside it. And whoever wants to consume it can call this use context with this particular thing, and utilize the value of it, right? So this is the concept behind the context. And how does it work is, basically we create a context first, and on that context there are two things: one is a provider, the other one is a consumer. So whoever is a like we can say, usually we wrap this provider on top of the uh, parent, which is the highest level of our state. Like the state is not going to be utilized above that, right? So as we discussed, like again, most of the things fall back onto the same principle of like React is under this hood is a tree. So we'll move it to the highest tree node, for which all the like for which any of the children needs it, but not above that. So that is the idea of the context. So so the thing first we do is we create a context, and it takes an argument of a default value, which is in case like if the provider is not found, this is the value that we'll be using. Then on the provider, there is a argument, required prop, which is which is the value in which we provide the value that we are going, which we are making, you can say, which we are allowing the children to consume, right? So this is the value that it will be giving. Okay. And how we are using this in here is, first, in the display part, we are just reading the counter and displaying that one. And in cases of increment decrement, we are consuming the counter context, use context, to get the counter context, and from that we are taking counter and set counter, right? So now this is a very generic implementation of counter context, as in like the context. Now here there are few problems that we can possibly point out, right?
Just the things are. I think we are a little over time. I get we can take it up in the next session either, or otherwise, if somebody is like very interested, we can stay back and like in general, I think others we can close off the session. We can take the feedback,
Sure.
or we definitely have a second session if like this is going on, right? Just so that in the interest of time.
Yeah. What I can possibly ask for is like a feedback on this one.